take high-end audio to the next level. So without further ado, and I'll let you introduce yourself and give us some more background, Gayle, but we're very happy to have you join us for this session, and welcome. And I'll turn it over to you.
Well, hi, everyone. Thanks for attending today. Great to see you all. So where's everybody from? Are you from Sarasota?
Sarasota, Tampa area. I think we have a couple people probably elsewhere in the country that found out about it from the MartinLogan forum.
Yeah.
Is there anybody here from the MartinLogan forum that's?
I am here from Delaware.
Wonderful.
Excellent. Welcome.
And there may be folks.
Delaware.
Oh, somebody's from San Diego. Okay, so we do have some others. There may be some people from your Facebook group, Gayle, joining in. Hopefully everybody realizes this is 1 p.m. Eastern Standard Time, not another time zone and missing out.
Right. So, as Alan said, I'm started Martin-Logan back in the 80s, developed the curvilinear electrostatic transducer, developed a product line, wonderful team. And then as it turned into 2000, there was an opportunity for me to sell, and I thought maybe it was time to retire and stop being the speaker guy for a while, just focusing on speakers. And, interestingly enough, I found, within those 10 years that I thought I was going to retire, that I just went right back to speaker design, that I just, I love our industry and hardcore audiophile and through and through. And and we'll go through a little bit of that. So what I thought I'd do today maybe is take you through a little bit of history about where I left off with the electrostatic transducer, go through some of the developments that we did, then take you on a quick tour of the Eikon Image 1, our technology and what it's doing and why it does what it does, and talk about something no one has seen yet, a couple of things that we're going to be coming out with in terms of accessories, new products, etc. Even show you some CAD files and some actual prototypes of where we're headed in the future. So what I might do is go ahead and take you on a little slideshow, unless we got any questions up front, and I'd be happy to answer them before I begin.
If I may, where are you at, Gayle?
Well, so I'm in my listening room at my house in New Canaan, Connecticut right now. That's where I'm speaking from, right? And behind me, we've got the Image 1, pair of my reference summits back there, which were given to me when I left. This is the original prototype summits with chrome structure in the back.
Oh, yeah.
And a couple of new little things too that we'll be talking about as well.
Cool.
Yeah. All right. So do I have share screen here?
You should be able to.
Yeah. All right. So I'm going to take us to there. All right. Does everybody see this? Are we showing the image here of my listening room?
No, you've got your desktop and the Zoom link. You can probably, you have to pick which application you want to share screen.
Let me make sure. Let's go back here. So one more time. How's that?
That's better.
Okay. So is that the listening room? We're seeing the listening room?
It does. It looks like you've got the big amount. Yeah.
So this was about 2000 or so, and I wanted to explore how far I could take the electrostatic technology. And so I developed this room where we started engineering. And you can see this edge here. This is a 300-pound granite plinth for my bassist bassist turntable gram tone arm. All the walls were audiophile construction, separate stud wall with sand around the entire perimeter for dampening.
Wow.
Acoustic damping all the way around, ASC tube traps, blah, 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 blah. We had up here a wave guide, a bass wave guide at the top. You can see here, that was the ultimate engineering products back in that day. And what I wanted to achieve was, as I said, how far could I take our technology? And so this was the statement at the time. Those of you that had a chance to listen to it kind of know what this is. Where right here, where my indicator is, this was our electrostatic transducer. We built this thing to be about 92, 95 dB efficient, and it would operate extremely well down to about 100 hertz. I wanted to get a subwoofer to operate at 50 hertz because I wanted total wave launch to happen at the size and scale of the room, where when I integrated our dipole transducer into the subwoofer. So that required designing and building, with Joe Voitko, who we talked about earlier, a dynamic dipole tower. So this tower operated from 100 hertz to 50 hertz. Again, super high efficiency, no compression, incredible dynamics. And then we transitioned into this subwoofer tower that you see back here. This is where we were starting to develop our balanced force subwoofer conditions, and which would then move into force forward, which now I've developed into wave guiding. And we'll talk a little bit more about that when we get into the Image One system. So, okay. So the subwoofer tower, got a little feedback there for some reason. Is that me? Well, anyway, this subwoofer tower consisted of 8 opposing 12-inch drivers per side. And it operated from 50 hertz down to like 18. No compression. It was great. It was quite an experience. Some of you may have had a chance to listen to it in this listening room. You'll see over here where my indicator is electronic crossover. Now, at the time, I was working with the promise of electronic crossover, of small signal crossovering, particularly high pass, low pass. We could get this to work with the subwoofer, but every time I put this electronic, even with the best designers in the industry at the time, we could not get this thing to really perform at the level we wanted to. So we had to go totally passive crossover after the amp crossover for the high pass of the system. So we're high passing at 50 hertz. So you can imagine the size of the passive crossover. I mean, the capacitors were just huge, inductors were huge in order to get this to accomplish, but it's still, you could hear the sonic improvements. Matter of fact, this whole chassis right here, this is a cast chassis, a specific proprietary casting. All it did was it just housed the passive crossover components and a power supply. It was quite a project, but it sounded extremely good. But those were some of the challenges as well. I found myself frustrated with some of the limitations even at that point in time. The filtering was not ideal. We still had to have a huge system to achieve subsonic bass. The bass was still, even though we're using balanced force, was hard to control in the room without a cluster of room control products, which controlled the room. I mean, it became a listening room. There were a lot of recordings that just didn't sound good, right? I mean, a lot of recordings are just EQ'd improperly. Still with passive components, I had difficulty getting the kind of precision. And that's with the electrostat. I didn't have timing issues because the electrostat's inherently phase correct, phase linear in its operation. But yet still we had those challenges. When you talk about passive components, a passive crossover, any system has to use, let me stop sharing for a second here. Any system has got to use inductors, capacitors, and resistors after the amplifier. So when you're driving your woofer, the signal has to go through this. So, you're spending, I don't know how much on speaker wire and cable and everything. You cannot connect your amplifier to your woofer. You got to go through this or this. And these are all storage devices. This stores voltage, releases it. This stores, this creates induction, and via that, then, your filtering. So it's got hysteresis, it's got resonance, all kinds of things that these components have that make them extremely challenging to operate with. And I found that, as I was saying, that was a big challenge back in the day. And I was searching for that component that would help us get to the next level in precision and performance and timing. So are we back? Does everybody have the my listing room here? Back again? We're back to the listing room?
You got it. You're good.
All right. So I went on a little bit of a journey, and I'll just take you through. This is kind of funny. Here's just a few of the prototypes that I was working on here as I started to kind of work my way towards what in the heck am I going to do. By the way, that's a electrostatic AMT that I was playing with at the time. Woofers, drivers, mid-range drivers, subwoofers, blah, 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 testing environment, et cetera, and with that, then started to unfold the Image One system. The thing that intrigued me during that period in time, as I was moving through all of this, was that digital streaming was starting to really appear, right? I mean, you talked about this. Here now we have uncompressed signals, particularly core buzz, where we have the opportunity to have a pure, uncompressed digital signal that we can now play with. And if I stay in that environment with powerful DSP, with correct DACs, I can do things that I couldn't do any other way. And that was really what enchanted me about this whole thing. And yet still become an audiophile, right? Thou shalt not compromise the signal. I mean, isn't that what we're all about, right? Let's be as pure as we possibly can. Let's take that treasured information and pass it through to our ear, through all those components, and get it to our ear in an uncompromised state. So if we say in the native digital environment, then we can do things that you can't do any other way. Huge flexibility in terms of precision, in terms of timing. We can work now in microseconds. I don't even have to worry about a driver. I can work at certain component parts of that driver and move those things in time. My ability to blend, my ability to wave shape, which we'll get to in a bit. We resolve EQ, resolve compression issues, and do that all at an audiophile level. That's what intrigued me. That's what enchanted me. So just teamed up with a bunch of great engineers, digital side, analog side, and kept working away. And we started to develop what we're going to talk about just a little bit, the Image One. But first of all, I want to talk a little bit about DACs. The first DACs was what, 16-bit, 44K? And actually, if you talk to the engineers at the time, that's really that noise floor, 16-bit noise floor, zero to noise ratio you could achieve with 16 bits, 44K beyond the point of hearing. You get jitter right, you get everything right. You don't need much more to create really good sound. But it's all about the reconstruction filter. This is the problem. This is the challenge. As we moved into 2496, things really expanded and became even easier. The challenge with a reconstruction filter, as you probably all know, is that or aliasing filter, is that when you're sampling information If the frequency response goes beyond the sampling rate, then you get aliasing. It's like we've all seen, spoked wheels on a movie where it's rolling, 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 and then all of a sudden it looks like it's rolling back. Well, that's the aliasing. That's because the sample rate of the video is actually slower than the rotation of those spokes. And so it's catching it at a different time and it looks like it's going backwards. Well, the same thing happens sonically. If you don't get those high frequencies out above the sampling rate, then you'll start getting information that is just unrelated and irritating. But you have to have a brick wall filter. In order to do that, then there's all kinds of issues like ringing, et cetera, et cetera, et cetera. And so you really have to be, once you get jitter and RF issues addressed, the reconstruction filter is really the big, big, big deal. And anything beyond 2496, it's kind of a numbers game. I mean, you have more area now than to shape the reconstruction filter, but still, even at 2496, incredible digital audio conversion can happen if the reconstruction filter is done correctly. And a lot of the things that we've done with the eye control in evaluation and developing the reconstruction filter are quite revolutionary. And how we test for that DAC is quite revolutionary, and we could get into that in a bit. But the point is that DAC in that system is, you could compare it to $10,000 DACs and it will stand tall by itself. And there's a whole issue of psychoacoustic understanding that goes into it as well as a 56-bit depth DSP engine. So we have this incredibly precise mechanism with which we can time align, we can filter, we can achieve, great purity, because this now allows me to directly connect the amplifier to each driver. So when you look inside this system, you'll see that, and we'll get into this a little bit more down the road, inside, so you have the DAC preamp in the center, we call the eye control. And then that distributes sound to each speaker, 4 channels of discrete information. So front woofer has an amplifier, back woofer has an amplifier, the mid-range driver has an amplifier, and the tweeter has a separate amplifier and a separate signal that has all the filtering, time alignment, et cetera, et cetera. And then inside the eye control, of course, is the master DAC DSP engine. And from the front, you can see here, you've got a manual volume control, you've got a mute mode, and then you've got the ability to access your different settings, your different inputs, and change your phase, your stereo from and invert as well. In the back, we have a few glamour shots of the image one in a living environment in the piano box, kind of fun to see here. And again, you can see a super tweeter, our mid-range driver, how it's mounted, and then the system here. I think the next one's going to go to a little bit of a, yeah, okay. So here is the insides of the system, and you can see the mid-range tweeter chamber up above. Everything's ceramically clad, first of all. The entire structure is clad in a ceramic laminate. Then at the top, then we apply a specific density wool fiber, and then we'll see a specific woofer damping material at the bottom. And then you can see the housing for the amplifiers, the 4 amplifiers direct driving each woofer. And then we have a terminated transmission line. What goes in there also is some filling that actually creates pneumatic damping internally to control the drivers, and then the 2 opposing drivers, which then we'll talk a little bit about that. We're using it in a balanced force mode, so there's not any reactive motion on the woofer box itself, but we also time align the drivers so that they launch in a guided waveform that launches the bass forward into the room rather than hemispherically or completely into the room. So we control how the wave launch occurs. And I'll talk a little bit more about that as we move forward. A little bit about the eye control here. You can see here the presets on the front and the inputs on the back. We've got both analog in balanced and line level and trim tabs. So if you want to use it for home theater or whatever, you can trim it into adjust for that. Digital inputs and then analog single-ended and balanced output, as well as calibration for microphone, et cetera, et cetera. And then this is the back plate for the Image One speaker with the inputs as well. And another gratuitous glamour shot in, I think this is Sapelli as well in a little environment.
Hey, Gayle, a quick question.
Yeah. Yes.
Are the amps all Class D, and are they ice power?
Yeah, they're Class D. They're kind of proprietary. They're proprietary for us. And again, as you can imagine, I compared them to the biggest and the best, and they are amazing, amazing performance quality, no compromise. Amazing.
I don't need any amps at all. I mean, they're all every one.
So that's a complete system, right? You bring a server to it, and we'll talk a little bit about that in the future. It'll have the room endpoint, but right now you bring a server to it, but then it's a complete system beyond that.
Yeah, could you talk about the drivers? Have you got drivers on both front and back, and do you have full range output to the rear as well?
So the mid-range driver is almost full range in and of itself, and in so many ways we think of the Image One as a full range system with a super tweeter and some subwoofers. The woofers themselves cross over at 150 hertz. And they work in an opposing manner, but we have digitally conditioned them such that they operate at low frequencies in a way that creates a null around the cabinet. So like, in fact, here, we'll just stop sharing for a second. So if you, the way they launch, we have a woofer in the front and a woofer in the back. And the way they launch creates a null around the perimeter. So it's minimally radiating into the room in terms of the sides, and it's launching energy forward into the room in a very uniform, even distribution in and of itself before we even get to our wave room control, which I'll talk about in a little bit. So they're digitally configured to go time lanes into the room.
So the spatial response is forward only.
Correct, and room oriented. It's flat down to about 22 hertz in this little bitty box. That's one of the things we're able to do since we control the amplifier, we control the drivers, we control the chamber. So we can reduce the box size. You know, if you reduce the box size passively, then at some point in time, then the bass starts to roll off. So what we can do is we can design all of this as a system so that as we reduce the box size, we offset it with a slight amount of EQ. And so we can get the box to be about half the size of a traditional system, yet still have significant bass extension.
The analog inputs, the first thing you do with that is convert it to digital so that you can do your magic. Is that correct?
Well, we actually do the magic in the eye control, and then it comes out analog to the
Right. But the analog inputs into the Eikon are converted to digital. That's the first step, right?
Yeah. Yes. Yeah. With super high sampling A to D converters. Correct.
Right. So I'm better off using digital inputs if I can manage that, right? If I don't have any turntables or anything like, I'm probably better off going that route so I can avoid the analog to digital conversion step, right?
Absolutely. I mean, if you come in digitally, then everything just stays in the native digital state all the way through. Correct. Now, we've worked really hard to get this thing to really sound analog, and I think you'll be quite impressed with it in its organic, effortless, natural, organic nature. And also, we have a number of customers that use turntables and are really happy with their turntable experience. In the control system.
Yeah. What is the if you input analog signal into that controller? What sampling rate do you convert it into?
Well, okay, so it is right now, it's converting at 2496. We will be converting at 24,192 and up to 386, accepting up to 386, but the native rate will be 192.
So you would convert the analog signal to
Yeah.
96K.
Absolutely, yes.
Okay.
Yeah.
So it's all PCM.
It's all PCM.
All PCM. Okay.
Right. Almost
and-
has to be, right? I mean, DSD is kind of a different thing, but everything's really.
So do you convert a DSD if you feed it a DSD signal? Do you convert
Yes.
it to PCM?
Yeah.
Convert
Yeah.
it to PCM.
Yeah.
How about your volume control? Is that done in the digital domain then?
That's done in the digital domain. Yes, absolutely.
Right.
Yeah.
So
yeah.
your
But we
Eikon
have-
probably has.
But we have
Sorry.
a 56-bit going to 64-bit depth
Mhm.
engine. So there's no compromise because
And then
of
your control unit probably takes firmware updates for your DSP algorithms and things like
Yes.
that.
right. Yes. So we can be in touch with all of our customers and update on the fly. Correct.
Hey, folks, why don't we let Gayle continue with this presentation and then we can hold our questions unless you're
Yeah,
really
right.
pressing relative to what he's saying.
I'm here for you guys. So, however,
Yeah, if you want to continue the presentation, then we'll
unless we have
continue
a
with
time,
questions.
right? Unless you need, say goodbye to me. Right?
We're good, however long you're comfortable talking.
So, everybody uses this for remote control today, right? So all of these features that, all of these features that we see that I've been talking about, and I will talk about, they're all accessible, as you can see here, remotely on the Eikon user app. And this is connected via Wi-Fi. So you could be in the kitchen and you can tell your system, what to do. And so, matter of fact, I'll screen share again, and I'll bore you, but I think you'll find this interesting, with the actual, what the system can do here. So here is the first window on the remote, and you can see here we've got balance, fine coarse, volume, and mute control. And then at the top up here, you can see volume, input, select, settings, utilities. And so moving into the inputs, you can see you can select from your phone USB, SPDIF, Toslink, RCA1, RCA2, XLR1 and 2. Then we have the mode select, and this is quite powerful. For those that want to have a home theater environment, you can then trim the system for home theater and also have it for audiophile settings, so it can work in either mode. Startup, volume, there are some presets. We'll talk about that. Contour, we'll talk about that. And then our wavelet room correction, which is quite exceptional. And we'll talk a little bit about that moving forward. So the next window, this is the contour section, for all basic purposes. It's an audiophile equalizer. But it's done in the digital domain, 56-bit depth, DSP. So we got different memories. So if you've got like your favorite Rolling Stones recording that just is horribly mixed, and you want to bump it up a little bit so that it's more palatable. So you can have the Rolling Stones memory bank for any of the, was it Capitol, I think, the recordings for that specific genre. That's what this memory is up here. And we'll go in the next window, will show us the actual, all of the windows, brilliance, low treble, upper bass, mid bass. These are audiophile settings tailored to audiophile requirements, and done in the digital, done in the DSP domain. And they really work extremely well if you want to add a little sheen at the top end or a little extension at the extreme bottom end, then, or add some dynamics. That's what punch is. It's actually just a very slight touch of an expander at the bottom end. and you can tailor where that happens, and then put those in those memory banks. I find that I don't use it very often, but when I'm listening to some music or TV or whatever that's not EQ'd correctly, it comes in really handy, and it doesn't compromise performance. And then here are presets, and again, these are really not, I don't use them too much, but they are like if you want to configure the entire system for some other use like home theater or whatever, then you can have different presets for different applications. And then finally, there's the as you were saying, there's the system update. You see there are software so specific. This is for a new system, and then we can upload, and update as we see fit. And then here's just a few more gratuitous glamour shots of the MH1 system. And finally, now we're going to get to the room correction system. So the eye control has a very unique way of looking at the room. You have, interestingly enough, there's a little kind of quantum physics kind of going on here. In the audio domain, you can either look very carefully at frequency, or you can look very carefully at time. But you can't look at both things. You may know where something's going on in time, but you can't quite see where the frequency is. Or you may know what the frequency issues are, but you're not going to be able to see them that well in time. And so this has been the big challenge. With FFT, you can see the amplitude of the signal, but you can't really see what's going on in the time domain. So we use wavelet technology, which is an advanced digital technology that's used, they use it in video algorithms, they use it in a number of areas. It's just out of the laboratory the last 10 years. And what happens is the system sends out this configured blip of information called a wavelet that then goes out, comes back, and it will tell the system what's going on in the time domain. And how you shape that wavelet will allow you to see a little bit of time or a little bit of frequency. You can't see all of each, but you can kind of recalibrate what's going on depending on the type of wavelet that you send out. So this is an FFT signal here. This is a typical room with a very good speaker system. And you can see here, that's what the room has done to the frequency response. And everybody knows, right? This is the amplitude, the volume of the signal, and this is the frequency response, 10, 100, 1K, 10K, 20K, right? And so this is your classic loudspeaker graph. Now we're going to go to a different graph here. This is a wavelet graph. Some of you may know this. This shows the same kind of thing frequency response wise. Here horizontally, 10 hertz, 100 hertz, 10K, 20K. But now in the vertical plane, this is time. And it's an 80 millisecond window. Why is it an 80 millisecond window? Because that's how long it takes base energy to build up in the room to where we can actually see it. So we configured this wavelet technology such that we can get a good idea of frequency and arrival time of information. And what you can see here is right around 1K, this is reflective, and this is spurious reflective information coming off of the room. Or maybe the speaker, depending. And then as we descend into the lower frequencies, oh, by the way, blue is very quiet, brown is very loud. The colors show you the amplitude of the signal. And you can see here in the base frequencies that they've been schmooed in time, as much as 20 milliseconds. So the base is moved in time, and we've got reflected energy in the room. So if you look at FFT-based systems, here they cleaned up that signal. This is equalized, right? Which is classic room correction systems that we see today. And it's pretty clean. It's cleaned up quite nicely. But let's take a look at what happened in the time domain. So now you see Those same room reflections are there, but now these things have become amplified, not, not ameliorated. And so that's why so many room correction systems have, a kind of iffy reputation, because sometimes they work, sometimes they don't, because they're not addressing these problems. Now, with the wavelet configuration, the way we look, when we room correct, the frequency response, as you can see, is better. It's not as dramatically better looking than FFT, but it's better than what we saw originally. Well, let's take a look at what happened to that information, to the all-important, to your ears time window. Look at that. So now, just a little hint of energy here, maybe a couple of milliseconds in 1,000 cycles. But look at how that base has been just really cleaned up in such a way that now it's just universally very evenly distributed throughout the room. And that's one of the wonderful things too, when this wavelet room correction system works. You can have a bright room that really changes things in base and time and all of that. And it makes a uniform, even sound field, that doesn't load up necessarily against the back walls or side walls. It's just very nice throughout the entirety of your room.
Gayle, where's that being measured from? Is the microphone where that's being measured at the sweet spot or multiple? Is that averaged over more than one spot?
Good question. Good question. It's been configured to take a measurement at 48 inches, I believe, on axis at the ear height, on axis with the tweeter. So everything's within the system. All the algorithms are calibrated to, they understand that this is going to be 48 inches from the speaker at ear height, on line with the ear for first the left speaker and then the right speaker. So you put the microphone in that position, you do a sweep, it takes that information, sends it up to our master computers, and then they apply out, and then we take the left channel and then the right channel. Then they apply algorithms to that and send it back to the eye control corrected. And it's that simple. It's a maybe 15-minute operation, 2 sweeps, and then it calibrates and then updates the system.
Could someone benefit from your technology if they have their own speakers and their own amplifiers?
Yes, the wavelet under certain, the eye control under certain conditions could be configured for that. We haven't done that, but yes, we could do that, yes.
I think actually doesn't Legacy Audio, I think, is utilizing that same
they have a
device.
they have a very similar core, their core DSP engine and their core DAC engine is very similar to what we have. Yes, very similar. Same engineering group, yes. We just use it in a very different way and use all of the components within the system.
I think this makes a lot of sense, by the way.
Well, it did to me. And I love exploring it, and it does. So what you see in the let me get back here. Yeah, so what you see in the image 1 back there, you can see the back system and the front system. It really, it's a small footprint. It's dynamic. It's effortless. You apply a bottom end to that thing, with a big bass drum or whatever, and because the mid-range has its own dedicated amp, there's no compression. The system just keeps rolling. It just keeps coming at you. And naturally, I wouldn't stop until I got it close to my electrostats in terms of precision, clarity, detail, resolution, all of that. But now it's got this small footprint and dynamics and dispersion with the dynamics are known for. So in so many ways, we've got our cake and we can eat it too with the system.
How about I guess one might argue from an audiophile perspective that the amp technology, the Class D amps in there, you're limited by the current state of the art, and being an all-in-one inclusive system, there's only so much you can do with firmware updates. But how far can you stretch this technology before you need to have new hardware?
Those amps are good. I mean, they're not as powerful as the most powerful amplifiers, but they, again, they can stay in the room with some of the biggest and best and brightest today in terms of resolution, detail, transparency, ability to create a sound stage, and organic nature. They're at the top of the game. Now, that doesn't mean to say that years down the road, we're going to find something better in terms of DACs, processors, amps, and all of that. But we're committed. I mean, if a person comes in, you know, our customers, we're kind of committed to keep them up to date, you know, at some reasonable costing, depending upon time. But we want to make it easy and upgradable and changeable. So all these components are upgradable and changeable as time moves forward. Absolutely. Yeah. And we kind of set that. That's why it's modular, kind of a plug and play thing. And even with the cables, we've got a couple of different categories with connecting cables and pedestals and all of the different accessories that come along with the product. So we can still have some audiophile fun with it.
So Gayle, now that you mentioned that this controller has 4 amplifiers per channel, is that what you said? One for the tweeter, one for the mid-range?
Correct.
Four amplifiers per channel. So are your speakers quad wired then, or
That is correct.
they're quad wired to each enclosure?
Right. Right.
Okay, but it's all in the analog domain once it gets
Correct.
out of the switch box, right?
Yes. Yes. Right, Joe.
Okay.
Joe, we've talked before, haven't we?
Yes, I saw you at Exponer. As a
Yeah.
matter of fact, you gave me a demonstration of the Eikon speakers back in the very first Exponer when you had it there.
Yes.
And we had a small 12 people or so in your room after hours, and we kicked back some beers and had some nice conversations. Yes, we went back to our audiophile histories.
Yeah.
An hour or so.
That's a glass of wine or two.
Yeah, that kept me interested. Absolutely.
Yeah. Now, by the way, also, Jerry Stakey is with me, and Jerry was with me in the early days as we developed MartinLogan in the sales side, and Jerry's come on board now, and he's working with me in both sales and operations. And so, Jerry, is there anything you want to add? I've been just jawing away here.
Actually, no. I think you've hit all the high points. I mean,
Yeah.
The thing to remember, a lot of times people talk about DSP and they go, well, I've heard DSP in Pro Systems, or I've heard it here, heard it there.
Right.
So different. I mean, DSP and Pro Systems work at 1644. I mean, our DSP works at 54. I think it's 54,384 right now. It's going to be moving up to 64-bit
That's right.
in the next 6 months.
Yes.
So
Correct.
when people talk about DSP and they can hear digital artifacts, oh yeah, absolutely. You can hear digital artifacts when you're working, you know, even at 8-bit, some Pro Systems are 16-bit. Using what we have now is completely different than what people that talk about what they did in the past when they were recording engineers. It's not like that anymore. And as far as the amplifiers go, that was a great question. And the ICE amplifiers that we're using in ours right now are actually very, very good. We compared them to all the other Class D amplifiers that we could. We have a whole shelf full of Class D
All the Class ABs.
And we also did a lot of comparing to AB amplifiers. And we're very comfortable with the performance we get from the amplifiers that we have. And one of the advantages, and you could argue, well, geez, you know, Dan D'Agostino's building these awesome amps, and he is. And, you know, Class A's got some new great amps, and Boulder. They do build great amps. What holds those amplifiers back is those amplifiers have to run through inductors and capacitors and resistors once they hit the speaker. So that compromises everything that amplifier can do. So you're not getting what you're paying for with those amplifiers, not to mention all the aluminum you're paying for in the finish cabinets and such. But with the way ours are set up, and each driver is direct coupled to the amplifier itself, it changes the playing field. It gives us a huge advantage in the playing field, which then gives you a big advantage in what you get for cost performance. So we can get the same levels of performance with an amplifier that you would argue is not expensive enough to be high end, but we can reach those very high end levels of performance by the way we utilize them in the system. So it's really all upside, and they don't suck a ton of power. You don't have to plug it in right to the power plant to make them run. I mean, they're very efficient. They have them sitting in your system and on all the time.
Are you have you developed a dealer network, or you're basically just selling direct in your?
Well, the dealer thing kind of went sideways on us.
Yeah, COVID.
COVID hit, and we had a bunch of dealer visits planned and a bunch of trips to go out and visit dealers.
Yeah.
And all of a sudden we got stopped dead in our tracks. So our sales have mostly been direct. We've actually done sales all globally direct. But yeah, it's the dealer thing. We really took it in the shorts when that happened. COVID hit. We were right on the cusp of getting out on the road, and we had to cancel everything.
So I presume the control unit puts out a signal that it's going to feed the output, right? The speaker that you have. So I presume that if you were to upgrade or change that speaker, then the control unit would need to know about that, right?
Right. We would reconfigure it for that, which is easily done, but it would be needed to be reconfigured. Correct.
Okay, so that's probably part of your.
And that can be done in the presets, by the way. So, you know, let's say it's some crazy future, you have different products and you want to use the same eye control with those products, you can then configure that in that preset mode that I showed you. So that can be accommodated very readily.
So all the crossover frequency tailoring is done in the digital domain as well, in the controller box?
Yeah, and so we can do exactly what the speaker requires. You know, we don't need to be stuck with Chebyshev or Linkwitz Riley or whatever. We can configure exactly what each driver needs in order to be frequency and time correct.
So if you can't get your hands on the same driver, for instance, and you have to modify one of the speakers, you can then just change it in the digital domain. You could just change the crossover in the digital domain within the software.
Yes. Yes, absolutely.
To give you a little bit of an idea, the advantage that we have over a traditional system is if we look at a driver and we see a little bit of a resonance at a particular frequency, we don't have to do a great big, broad band EQ to fix that little bit of a resonance or a notch in a driver. We can specifically attack that particular part. So we can manage a driver in ways that no passive speaker manufacturer, it's impossible to do passively. I mean, the only way you can really do it is when you control the crossover, it's 100% the digital domain, measure it, make those filter adjustments. So that little bit of a ripple that is every single driver made has a little bit of a resonance or a ripple or some weirdness. I mean, they all do. And we can measure those weirdnesses like everybody can, but then we can correct for them like almost nobody can. And
all dynamic drivers have those conditions. And by the way, we're working on a technology that will go beyond that down the road. So stay tuned.
So we're talking about making modifications from batch to batch, like you get a batch of woofers, you get 1,000 woofers, and then next week you get another 1,000 woofers. And you can do that kind of tailoring without redesigning the whole thing.
Well, and we do a bit of that, but also the wavelet does that just by itself, because it looks at the speaker, it looks at the room, it looks at the whole system, and then re-corrects whatever aberrations are there, as we saw in both the amplitude and the time domain. I mean, you've got to, you know, it sounds better if you get the speaker set up correctly. It sounds better if you start with an absolute audiophile product. But within those conditions, then the room correction system can go in and recognize any of those personality differences from one driver to the other and resolve any of that. But we do tailor match.
But there is a certain slope that you're dealing with when you're going from in a four way system, right? There's a certain slope that you're dealing with. So there has to be some decision as to where that improvement is allocated to, which driver it's allocated to, depending on the way the speakers match, the drivers match.
See that again, Joe.
Yeah, in other words, you're saying that the room correction already takes care of those anomalies in drivers, but I'm saying there's a certain amount of leeway and slope that you have in frequency response from driver to driver.
Oh,
So there has to be some decision made in the digital land as to where to allocate that correction, in which driver to allocate that correction based on the slope of the drivers that intermingle.
well, you've got, okay, so you've got a specific woofer and a specific mid-range, and they have specific characteristics. Now, within those specific characteristics, there might be some subtle little aberrations, but where they have a peak or where they roll, how they roll off of the top end and the bottom end, which is kind of the all critical area, that's pretty close. I mean, they can move a little bit, but that's pretty close. So we do some individual tailoring, but we find that traditionally the quality of the drivers that we're using, that we don't need to change the actual slopes of the crossover points in the drivers themselves.
How about multi-room? Have you considered the notion of me having, say, for instance, a set of speakers in one room and another set of speakers in another room, but being driven, since the amplifiers are, per speaker, right? They go with the speaker. Why not have the same control unit for both rooms?
Well, it's kind of like it would be better to have separate eye control. Now, you could have a separate system on the system, and that would be operable from the remote. But it's best to have one eye control per each system. But you could have two systems and then run them from one remote. That's for sure.
Hey, Gayle, Derek had posted a question in the chat about what's the small stand mount speaker. I guess that's your little tease of potential future product.
Hi, Derek. Good to see you. Derek is a Image One user, as a matter of fact. And Don is too, as I remember. Yes, we're going to talk about that a little bit. That's a project. This is the first time I've talked in public about that and what we're seeing. I'll show you the images on the screen here. This is the new, we've codenamed it the 0.5. This is our bookshelf speaker using the same eye control, same wavelet format, but adapting it to a bookshelf. And by being able to do that, we were able to really get some incredible extension. This thing operates down to about 35 hertz as a bookshelf. And then we've tailored it such a way that as you turn it up, as it gets above, I don't know, average SPO above 100 dB at the listener, then it starts to, the bass kind of stays, to protect the woofers, then it kind of stays the same as you raise the level, but it's hardly noticeable to volume levels because they're.
Is that a sealed speaker? A sealed cabinet?
No, it is. It's a specific vented port that we use with our transmission line damping format internally. Yeah.
So is it a rear port or
rear port?
The port?
Correct. And so we now have capabilities. We do all of our design work in CAD, both the electrical filtering and as well as the physical modeling. So these were images that were converted from a hand sketch into 3D modeling. And then, so these are actually not the real speaker. These were the 3D models that we wanted to design from. And then we take those models and we put them, I'm grabbing something here, into the VR environment.
Huh, huh,
And so we do all of our prototyping now in VR.
huh.
And which saves time, gets us much faster design analysis, and we can get much closer to the end rather than going through 3 or 4 or 5 prototype models, physical prototype models. We can do that iteration process in the virtual reality environment, and then get to an actual physical model much faster. Now, this is the physical model. We just got these done a couple of weeks ago, so you guys are the first to see. This is the new 0.5 with the grill on, and I think this is with its audiophile grill, so you can listen without grill cloth. Oh, and then we're getting to the grill for the image one itself as well. Here, let's see. This is some pedestal configurations that we're working on as well, which is what you see back there. This is that's the image one with the grill and with the and its new pedestal arrangement there. So, like, if we look at, so here's the little guy. Now, this is the new little bookshelf. And it's really new. This is great. We're using neodymium magnets to attach it. And this is just a super dense composite board for the grill. I mean, when this thing goes on, it's like clack. I mean, it's just rock solid.
How about a quick demo?
Come on over. Absolutely.
Where do you cross the super tweeter over in both models?
About 4K, about 4,000 cycles. About an octave above, octave or 2 above where you normally. And that mid-range is so good, it extends quite nicely out to 4K.
Are the mid-range drivers the same on both models?
Yes, yes, that is the same driver that we use in the Image One. And that's kind of why I loved it so much, because, you know, the electrostat, MartinLogan electrostats were so phase coherent and so uniform in their wave launch. And how you get that, right, is a full range driver. And so this mid-range, this specific mid-range, built in Italy for us, and its extension was so good on both the bottom end and the top end that I could use it as a full range system. And that's what enticed us into also doing a bookshelf, because it performs so well. It's like a full range driver, as I say, with a super tweeter and a subwoofer.
So Gayle, looking at the large speakers, the 1s and the 0.5s, that looks like an ideal basis for home theater.
Yes, that too. Absolutely.
So are you going to have a surround processing capability in the near future?
Good question. I think we definitely want to take a look at that. That's not on our chart right now. I think there are some of our team has spoken with that, and we've got some expertise in that. And I think we might be looking at that, particularly down the road, as we start to enter into, you know, right now we want to, it's about music, it's about stereo, it's about refinement and ultimate creation of a stereo music experience. And, but as we grow and as we expand, certainly home theater is a component, and working with the surround algorithms makes a lot of sense. I don't know right now that any of us are too happy with the surround sounds that are going, I mean, with configurations that are available, but it would certainly be fun to experiment with it and see if we can bring an audiophile attribute to that whole experience. Yeah.
So
Yeah,
mean-
could you give us some idea of the pricing of the gear?
Yeah, well, okay. So the Image One system, as it sits right now, is 25,000. It might be going up. We will have an update to the iControl, which will update a couple of its user features. It's going to have Bluetooth streaming, Woo endpoint. I think I could say that today. Again, you guys are the first to know. And that's going to be probably coming out in June or so. And we'll have an update for that. Derek, by the way, Don, we'll have updates for that. Hopefully we can keep it at the same price. We'll have to take a look. But the Image One is 25,000 today as it stands. And the 0.5, we're still massaging its bill of materials, but I'm sure we're going to withstand. We're going to be able to be in the $15,000 price range or something like that. And then we'll also have a tour de force subwoofer project that we're thinking about to accompany it down the road as well.
So you basically get preamp, amp, speaker, all tuned to work together
Right.
for that money.
Correct.
Sounds like a bargain.
Thank you. It is. Derek, what do you think? I mean, when you get that in your room, I think you'll find that to be the case.
I think that Derek actually had to drop off, but you could ask David or Don.
Oh, David Solomon's with us. David, are you there?
David, you're muted. You can unmute.
I am here. How are you? Been just sitting back watching everybody. It's been
Mr. Solomoni, how are
Hello,
you?
Mr. Gayle. How are you? It's good to see you again.
Excellent, excellent. You've had a chance to experience the Image Ones. What's your thinking?
I've had many high-end systems, and that has been my favorite system I've ever had. I can't believe it either because, you know, I was listening to a few of the guys talk about digital anomalies and, you know, the things that you would typically talk about with a digital-based system, and you just don't hear it. I want to hear the digital on these things, but I just can't. Everything just sounds too analog. I've got my VPI Prime hooked up to one of the analog inputs, and I mean, I just get a great experience with the whole thing.
Now that's an important point. What is your turntable experience, your vinyl experience?
It's analog. It does not sound digital at all.
Yes.
I work for Cobus, and you know, obviously I listen to a whole lot of digital stuff, but I listen to a lot of analog too, and always have. But you want to hear it. You want to hear the digital part. You're going, how is this digital? But we've passed that, guys, and the amplifiers as well. You say what you want to about the iSamps, but they're fashioned perfectly to the speakers. They're fashioned the way they're driven to the speakers, the way the slopes are working, the way the crossovers are working. They're just transparent. I guess would probably be that's such a cheap word though, but they're transparent as hell. You don't hear the boxes. It has been my favorite system just because of the usability. And Jerry was talking about they kind of take the best of the pro world. They do. That's what I've done that my whole life as well. And if there's one thing pro guys have got going for them, they never put a pair of speakers in you and leave them. Yeah, some of these like big arrays, they're $500,000 a piece. You don't find people like this dropping an array in and just going, okay, you're done. Oh no, you maybe need to move it a little bit more from the wall. They're timing each driver. They're crossing each driver over. It's just the way things should be done. And I told Gayle this when we first got together. I helped him launch these at Expona. It was quite an honor. And on this 16, 18-hour drive Gayle and I had from Connecticut to Chicago, I kept telling him, I'm going, you know, I've been in pro audio all my life. I've been in consumer audio all my life. I can't believe more companies aren't doing what you're doing, because nobody's room is right.
Well,
But with the icons, we can make the room right.
and you talk about time, I mean, I think it goes without saying. I mean, a lot of companies are making a big deal about time and the ability to resolve in the time domain. We can resolve each driver a microsecond at a time, and each component within that driver a microsecond at a time. It's just, what a powerful tool.
Let's see if my mic's working now.
Oh, there we are. Hi, Derek.
Hey, Gayle, how you doing? Just to let everybody know, I was first install
Yes.
of the Image One system. So Gayle flew out from Connecticut to California to do the install. And it took about, from opening the box to set up, probably less than an hour. And then we were singing. And I've been using it ever since and absolutely adore it. Great product, great value. Love every minute of it.
Thank you, Derek. Thank you. Yeah.
I'm curious. One of the things I think the advantage, certainly, Gayle, of this technology is we all struggle, I guess, with the time alignment aspect of our systems. I've been struggling with that, even with my MartinLogans, trying to dial in separate subs, and it's been so difficult. So this seems to be an all-in-one system to optimize that. But how close to the back wall for the main Image One? How close to the back wall can they be and still get optimized timing and such?
Well, you still have room interaction and all of that, but we've found, I mean, you could get them as close as 6 inches to that back wall, but typically it's good. The system likes to be asymmetrical to a corner. So if you're a foot from the back wall, you want to be 18 inches from the side wall. You want to have different, you don't want to have equal distances from side wall and back wall. But the ideal situation seems to be, I would say, I don't know, David, Derek, what's your experience? My experience is about 18 inches from the back wall seems to really.
Yeah, well, mine, as you know, is in a family room. And they're aesthetically very, very nice, by the way. But in the family room I've got them in, which is not asymmetrical, they're in a sort of great room type situation. I think they work absolutely perfectly. From one wall, from the back wall, they're about 2 feet away from the back wall. Left wall facing is, 8 feet, and right wall facing about 10 feet, and then it blows out into an odd L-shaped room. And you can hear the difference because on the eye control that Gayle talked about earlier, the app on the iPhone, you can actually switch dynamically between using room correction and not using room correction. And, it highlights the value of room correction when you do that switching.
And yes, a good point, Derek. And I mean, sometimes we go into a room and there's a lot of glass or hard surfaces, or the base is wonky, and there's just nothing you could do about that. I mean, that is what it is. Or you've got to put your speakers in non-uniform situations just to make it work in the room for whatever reason. And the wavelet correction system really comes into really shines under those conditions and will create a more ideal result in unideal.
By the way, the name eye control, I presume it has to do with the shape of that graph you showed us, right?
The eye control? The
eye, right?
The eye.
Yeah.
Actually, it just came from the fact that we called the company Eikon, E-I-K-O-N, and it's more like, well, what are we going to call this thing? And I said, well, let's call it controls everything. So let's call it the eye control.
Hey, Gayle, I've got a question for you. On upgrades, you mentioned, someone asked earlier about the amplifiers and potential upgrade paths there. And rightly so, you said these amplifiers are extremely good and should last a long, long time. Most of us in the audio will require amplifiers for a long, long time. But DAC technology is a different question. I mean, DAC technology is moving fast. And while I appreciate you've got extremely good DACs inside the eye control, how do you take into account the new DAC technology, such as ladder technology and other technology that's coming on the marketplace?
Well, Derek, actually, ladder technology is what's old is new. ladder technology was kind of what some of the original DACs used, and then we went to Delta Sigma and whatever. So again, it's so much, okay, sampling rate, jitter, isolation from RF, extraneous energy, and that reconstruction filter. And those are kind of the fundamental building blocks.
Mm-hmm.
And you get those right, and that's going to trump any new number or whatever for the most part. Now, that's not to say that we're not going to advance things. We are. And we will be advancing our DAC, and we'll be making that available very cost effectively. But again, it's going to be pretty subtle.
Thank you.
It's so darn good already.
I agree.
Is
By
it
the way, for the
possible-
others as well, I did try an analog front end by putting an alternative DAC in front of my system. So I went from analog to digital or whatever the sequence is. And there's no doubt the digital input was the analog input was as good as the digital input.
Analog's a really high performance A to D converter. Now, Derek, are you using a turntable at all?
No, I'm just using the Blue Sound Note 2. I'm, for David's benefit, I'm a totally Cobus user now, 100% Cobus.
Yeah. Cobus.
Gayle, as Jerry knows from setting up my system, I'm a big vinyl guy, right? And
Right.
Jerry, I've actually upgraded my turntable since, you put the VPI, in there. It's actually, I got Triangle Art Anubis, and, it sounds absolutely phenomenal through the system. It actually sounds better than my analog does. And that's because I need to upgrade my analog. It sounds better than my stream because I'm streaming through a Roon nucleus. I probably need to get a much better streamer. Yeah.
It's that good. Wow.
Yeah. Gary Ekmeyer, you had a question, I believe?
Yeah, if I could ask my my usual elephant in the room question, since we have Gayle here. Gayle, you made the MartinLogans, which are dipoles.
Yeah.
And now you're making speakers that have a direct only output. I believe that Mark Davis said that what we hear about speakers in rooms is frequency response and radiation pattern. Why the change?
Great question. I kind of, to my way of thinking, the electrostat, the curvilinear electrostat, the MartinLogan curvilinear electrostat was a pretty significant jump in technology and a nice contribution to our industry. I hope it's looked at like that. And the boys, the team, I put this team together, Joe Voitko and his engineering team, and together we kept moving that technology forward, consummating it under my lead in the statement. And then Joe and his team would kind of advance that farther, but it's minuscule and subtle. And so, yes, I could come out with another electrostat and I could maybe do something better, maybe not, I don't know, whatever. And I love electrostats, don't get me wrong, I love them. But I saw something significant that could be done here with systems integration, using the best DACs, the best SAMP, the best DSP, and putting that all together and resolving all of those problems that I was going to do when we developed the statement. And maybe even some more, which is what has happened with the wavelet room correction and all the wonderful things that kind of unfolded as we put the image one together as a team. So that's about the electrostats. About going from dipole to monopole. The dipole has a specific wave configuration and room integration that, particularly with the curvilinear, MartinLogan curvilinear stat, that I just really love, and that is the curvilinear line source. The fact that it's 30 degrees horizontal, it's a line source vertically. So there's minimal interaction with the room, at least for the energy that the speaker is performing, the electrostatic.
A dipole has minimal interaction with the room?
A dipole has minimal immediate interaction with the room in that there is a null on the perimeter. So it's not hitting the perimeter of the room in the same way that a monopole is, number one. Number two, particularly our curvilinear line source is very controlled in its dispersion pattern. It's a 30-degree dispersion. If you take, that's why I had to curve it. If you take a large transducer relative to the wavelength that's reproducing, it gets progressively more narrow in its dispersion. So a large flat panel electrostats, when you listen to them, I know you all have experienced this, it's like sitting in a vise. You got to sit in one spot. You can't even move a half inch or the frequency will shift and change because they're so directional due to that phenomenon. So by curving that, I was able to take that specific phenomena and open up the window to a 30-degree window. So it minimally interacts with the room in the horizontal plane. And since it's very tall, it acts as a line source. It pushes forward a high frequency, mid frequency, small wavelength launch directionally, very directionally. So it doesn't interact with the room, with the floor or the ceiling nearly as much as a monopole does. That's what I was saying.
But it has equal output to the rear as to the front.
But that's late arrival time. And so what happens is that reflective energy comes back at you, and you're, due to the way we hear, that's perceived not as information relative to imaging, spatiality, detail, yada, 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 and more about ambience. It creates an ambient sound field. So typically, inherently, dipoles interact in a way that give you late arrival information, adding more to the ambient reverberant characteristics of the signal.
Right, that's what I call
deeper sound stage.
That's what I call the spatial response of the speaker. That's what gives you the spatial effects and the depth of the image.
That's right, Gary. Yeah.
You're missing that in the new speaker.
Yeah. Yeah. Now, so we still have those issues that we have to deal with, but with the wavelet analysis system, so much of that can be ameliorated and you can really hear it, you know. So we get the space depth, we get the detail, we get the resolution, as well as all the other aspects of off-axis listening, dynamics, that just really, you know, upfront, effortless, easy dynamics, you know, with the drum solo or piano percussivity. It just, that wavefront, just because it's time coherent and it's uncompressed, I mean, it just hits you. It's like, oh, that's a piano, man.
Gary, why don't you tell Gayle what your background is, your perspective, as you got your own design of speakers that include front and it's a dipole, more or less, design.
What are you doing?
That would get, I'm not any audio biggie. I just am an amateur, but I believe that the radiation pattern is what is key in creating the sound stage in front of you. In other words, speakers don't put out their sound to your ears, they put out the sound into the room, and you're not reproducing audio signals, you're reproducing an acoustic event in front of you. That requires direct and reflected sound that creates the sound stage that you hear. Without the rear radiation, you have a lot less depth and spaciousness in the image. So I designed and had somebody build me a speaker that had a variable radiation pattern so I could check that all out. What I ended up believing in was the dipole. If you place a dipole properly in a room that has proper reflectivity around the speakers, you can manipulate this sound stage very audibly, and that can't be done with direct firing speakers.
Sometimes Yeah, right. I mean, how many times have you listened to a speaker? How many of you have heard a speaker in an anechoic chamber? Doesn't sound very good.
Mm.
No, but I agree with you on those acoustats that are a flat planar full range electrostat. I sat in front of those with a demonstration in a store once, and I thought my ears were going to be sucked off. And they have no spaciousness whatsoever. They have only direct sound, and they don't even interact with the room at all. I don't know.
But Gary, I just want to interject something here. For somebody who has owned omnidirectional speakers for over 30 years, is a speaker really supposed to manufacture spatial qualities? Is that really the role of a speaker?
That's a $24 million question.
It's one of its most important roles. And for
I'm
an
not so
example,
sure that's true.
For an
not
example,
that I agree with you, but I'm not really sure that you have to build in ambience in a speaker that's not built into the recording. That's just from somebody's aspect who has owned omnidirectional speakers for as long as I have.
I'll get off the stage, but I just want to give you an example. For example, MBLs are a highly appreciated speaker in the industry, and they always have the biggest room in these shows, and everybody really likes them. That's because they're omnidirectional. Omni is almost as good as dipole, but they're both good at creating spaciousness in sound, let's say we say.
I would add that
I've heard
I think that a well-designed speaker is the first and foremost fundamental step. And I think that the time alignment and control of that, I think, is critical to the musicality and the reality of the music. If you've got an omnidirectional speaker that's poorly set up, and you're just getting, basically everything blending together and muddy because of reflections, that can sound poor. Properly implemented and time aligned primarily front driving speaker, I think, could best reflect the recording. I think you have to hear it to judge, obviously, ideally hear it in your own room and your own setup. I hope Gayle will have them at the Florida Audio Expo.
I hope so too.
So we can all
fully intend
listen and
I was going to say a little bit about this omnidirectional thing. Yeah, there's the back and forth, and so much of it's about implementation. But most omnis that we hear, MBL being one of the exceptions, because they're fantastic. I totally agree. I've heard them on a number of occasions, and I'm very impressed. Off axis, on axis. But so many omnidirectionals typically will give you an ambient sound field for whatever that is, but you're going to start compromising image focus and specificity and intertransient detail. You can't have all of it typically. That's a good field of study, though, Gary, and that's in the back of my mind to really look more deeply at radiation, at how to widen that sound field off axis listening and yet retain the treasured intertransients, detail, resolution, image specificity, downstage, all of that. And
the room positioning of speakers is also extremely important. You can have a perfect speaker as far as frequency, radiation pattern, and all that, and you can screw it up royally by mispositioning them in the room. And if they got to be away from the walls and positioned in a certain way so that the reflected sound is also shaped in that sound stage as well as the direct sound.
Some of that's true, agreed. I think, again, this is why we have this wavelet technology at our disposal, so that if you do get into a compromised situation, which so many of us do, the wife factor or whatever, that we have to, put these things. We don't have a specific man cave that we can put our product in, that the wavelet really helps us retrieve so much of that, even in a compromised situation. That's why we have that room control. And that's why we stay in the digital domain. It's the only way we can accomplish these next level of audiophile level performance characteristics for the future of how we're going to experience the musical event.
Yeah, it'd be interesting to, if you were to employ, you've already got a rear firing woofer, but you have that set up for the base forward purpose. If you had a rear tweeter, as some speakers add, for some ambiance, that could easily be dialed in utilizing your wavelet technology, where you could dial in the amount of ambiance you want.
Not without rear drivers for the high frequencies as well.
That's what I said. You'd have like a rear firing tweeter.
Yeah. Yeah. It'd be an interesting project. Once we get some of this done, we'll play with that and report back.
Actually, the problem with doing that is that you then need another amplifier so you can time delay that rear tweeter. And then you'd also have to have another output on the eye control. It's a lot bigger project than it sounds like if you really want to do it properly.
Oh, we just stack up 2 eye controls, Jerry. Okay.
What is Gayle? What is your email address?
Gayle, Gayle at Eikon, EIKON audio.com.
Thank you.
Alan, we could put that on the site if you want.
Yeah, I'll add that to
Gayle at Eikon audio. Yeah, love to hear from you guys. Absolutely. Any questions, chit chat, updates?
Unfortunately, one of our longtime members, AJ, who is a speaker builder, Soundfield Audio, emailed right before he couldn't join us today, but he designs basically a very similar concept. He's a small boutique kind of hobbyist speaker builder with dipole designs utilizing digital signal processing and so forth. I'm sure he would have had a lot to offer in questions, but he couldn't join us today.
Would have enjoyed his participation for sure.
Yeah, John Shake too. Dr. John, he builds his own speakers, and each driver is individually amplified, and everything's controlled in the digital domain. He would have loved to have been, but he'll be watching the recording. I can guarantee.
We'll have to send him an eye control.
He would probably love that. He'd probably also take it apart.
Yeah, exactly, absolutely.
I think it's fascinating technology, and I'm a firm believer that I think more speaker manufacturers will start to employ this. I know I actually just ordered the new Anthem, one of the new Anthem receivers for home theater, because with the Anthem room correction, I'm hoping to get better integration for home theater with my system in the MartinLogans, and of course MartinLogan has now utilized Anthem room correction in the bass.
I hear it's pretty good in the bass. I hear it's pretty good in the bass. The guys tell me they have good success with it.
Yeah,
and of course, the MartinLogan guys are co-designing that, so they're going to be really focusing on how to integrate their dipoles with the bottom pole or classic subwoofer.
Gayle, what is to prevent your controller to have an electrostatic on the front end? I mean, why couldn't you integrate a panel into your design?
I can, absolutely.
Then you could address Gary's concerns about the rear reflections and all of that stuff, right?
No reason not to. And most certainly that's not out of the question that someday we might again play with electrostats. I mean, I certainly have some ideas what I'd love to do in terms of future design, and maybe even integrating ribbon in electrostat technology in a way.
Right.
Yeah. I mean,
and did you ever
all those fun things, once we get up and rolling are there.
I mean, you could put the amplifier at the, on the speaker itself, just like you do now, and then have the Eikon do what it does, except the output is different. That's all.
Well, and yes, and with being able to control it, we could also work with its unique dipole characteristics and integrate that wavelet-wise. It would be very interesting. Very interesting.
Gayle, is the tweeter you're using now an AMT driver, or is it a ribbon driver?
It's an AMT.
It is an AMT.
Mm-hmm. Yes.
So that easily could have a rear reflection. I mean, if we're delving into that, not that I'm a believer, but I mean, that naturally has a rear reflection in AMT.
Well, actually, this is an enclosed one. It's got a neo. Right. The driving magnet force is actually behind the AMT. Mm-hmm. So this is really a forward directing driver in and of
Mhm.
itself. But that's not to say that we couldn't develop something that is a dipole AMT.
Mhm.
Out of curiosity, where are you manufacturing these currently?
Well, up here in Connecticut, right now we're we're in process. We've got a little facility, design and manufacturing facility here in New Canaan, but we're moving up a little bit farther forward to a lovely, oh gosh, it's an ex-Cannondale display environment. So it's got, it's 20-foot ceilings and track lights and climbing walls and all this crazy stuff. So we'll be integrating our whole team in there, and we'll be putting, you know, state-of-the-art CNC router, state-of-the-art spray facility, as well as all of our CAD design and the VR products all together in that new space. So I'm really excited. We'll have all kinds of flexibility to kind of develop in a bespoke way where we kind of have the ability to build at our customers' needs, to accessorize and customize at a much higher level.
Yeah, they're gorgeous speakers. For those of you that had the opportunity to see them, definitely a very high wife acceptance or spousal acceptance factor, which is a reality that we all have to deal with. So that's a big plus, and it makes it a simple system, almost a plug and play, so to speak.
Well, that was a big goal of mine. You know, MartinLogan, I always had to deal with that large electrostatic transducer, and as much as I loved it, it was really challenging to watch all the dynamic boys come in with these smaller products, you know, and oh, they have better wife acceptance factor. I'm going, man, how do I design around that? And so the design of the Image One, that was another one of my passions, was to really create an object that people would enjoy in their living space.
Gayle, maybe you could just enlighten us a little bit about an optimum space for the Image Ones. I mean, what was your goal, design goals, as far as a domestic environment for them?
Well, a typical room, just like this listening room that I have here, you know, 15, 20 feet wide, 20, 25, 30 feet deep, 10-foot ceilings, solid floor, some probably carpeted, some soft materials in there, not all hard.
Mhm.
You know, the old JBL rule of thumb always fits so well. If you got one hard surface, you want a soft surface opposing. You know, you don't want all hard, you don't want all soft. Solid walls, solid ceiling if possible. That was the environment that I designed this for. And I wanted to be able to have a small footprint, but be able to have full bandwidth. I mean, these woofers are subwoofers. They get down to 22 hertz, and they are effortless, and they're weighty. When you hit a bass drum, you feel that thing roll across the floor, and you feel instantaneous barometric pressure change as that thing rolls across the floor. And yet there's attack and there's resolution. So that's the space. Not a large. They still work in smaller, even yet still spaces, but I wanted to really attack that size space because that's more of our traditional listening rooms. They work extremely well in very small environments as well too, like giant bookshelves, right? Giant earphones. But I wanted them to be kind of uncompromised in a classic listening environment.
Pants flapping bass.
Pants flapping bass. Absolutely. Yes.
You know, Gayle, you mentioned that you're playing around potentially with subwoofer as well. Would that also be time aligned, utilizing the wavelet technology? How would you implement that?
Yeah. Well, you would bring a subwoofer in below 50 hertz or lower if you could, because we really, I mean, and it would be in a larger space. I think most of us, Derek, what are you finding? I think most of us will find their extension in most rooms is quite adequate.
Yeah, sure. I have them, as I say, in the family room, and whenever I get any visitors, there's a particular Beyonce track that goes down to about 25, and I use that to demo it just to show how low they go. And I know that you use that track actually at one of the shows.
Yeah.
So they do go down very, very low. I don't think, you're obviously thinking subwoofer, but for an environment like mine, I just can't see the need.
Right. Once we get into a larger space, taller ceilings, bigger room, naturally then to support that kind of pressure front, because we're talking 20, 40-foot wavelength. And
Right.
you get that into a large room, then augmentation with subwoofers does make sense. And yet still that wavelet analysis correction will still work in those large scale rooms. They work in a commercial environment. We're even thinking about using this in commercial application
Sure.
as well.
By the way, if any of your other listeners want a quick trip out to California for a demo, they're more than welcome. I know it's a bit of a distance for them.
Well, Gayle, if you want to come down to warm Tampa right now, I think it's about 76 degrees today. I did a 15-mile bike ride this morning in my shorts.
We have been socked in. I'll tell you, we've had so much snow and rain up here the last couple of weeks. It's not funny. Just the last couple of days, it's opened up a little bit, but for the most part, it's been just like, ugh.
Well, thank you, Gayle. I appreciate it. Nice presentation.
Hey, Gayle, are you going to expo?
If we absolutely, if yes, that's our plan.
It's August, I think, isn't it?
July.
Yeah. Well, guys, thank you so much. It's been a pleasure talking to you.
Gayle, thank you. That's fascinating. We'll be very anxious to see the further developments and get to hear the system again, hopefully at the Florida Audio Expo.